Remember what I said a relation is? A relation is simply a map from one set to another set, right? When we assign values of one set, when we assign So hello and welcome back. We want to particularly look at now some examples of relations, right? But before I continue, the last thing I just want to mention is that the members of the objects in a particular set, they are called elements, right? So let me just put that down. Elements. What are these? These are the members of a particular set. So if I say X is an element of the real numbers, I mean X belongs to the set of real numbers. So elements, members of a set, are called elements. Righto. Okay, so let's look at a few different relations. I'm going to start with one. Let's make it a blue set over there, and let's take another one, which is going to be black. And remember that the set over here from which we assign objects to, which we map from, is called the source, and which we map to is called a target. Right, aka the domain and aka the codomain, not the range, right? Okay, and by the end of this video you will get a clear idea of what we mean the range is. So I'm just going to select 1, 2, 4, 8, 7 over here and 9, and then I'm going to put about 5 or 6 different objects over here. Let's make it a heart again, let's make it triangle, let's make it star, let's make it dot, and then I'm also going to make it circle. So 1, 2, 3, 4, 5. Right. Okay, so when we start mapping from one set to another set, for example, 4 is assigned to heart, while 2 is assigned to triangle, 9 may be assigned to star, and 7 may be assigned to dot over there. Now clearly what you can see is that not every single member in here is assigned to a value in there, and that's also okay, right? It just means the values in the source, we can take on values such as 1, 2, 4, 8, 7, and 9, and then this again, I'm mapping from the source, the set A, and I'm mapping to the set B. And I can also express this in the form of, coordinates or an n-tuple that looks like such. 2 maps to a heart, 2 maps to triangle. So I can express it as 2 mapping to triangle, 4 mapping to heart, right? 9 mapping to star, and also 7 mapping to dot. Okay. So there you can see I've given you a visual representation, but I've also given to you in terms of an n-tuple, or looking at it in terms of coordinates. Now this here is simply a relation. I'm mapping from the set A to the set B. Okay, let's look at another example. Okay, where we are now going to do something similar. I'm mapping from the one set to the other, and that's 1, 4, 7, 9, and 2, and 13. And then again I've got heart, triangle, star, dot, and I've also got spades over there. Right, I've got a spade over there. So let's again map certain things. 4 is mapping to that, and in this particular case I'm going to map 4 to heart as well. I'm going to map 9 to the star, 13 to the spade, and I'm actually going to assign values to everything over here where that maps to that. So if I were to express this in terms of the coordinates that you did previously, I'm going to map 1 to triangle, 1 maps to triangle, while 4 maps to dot, 4 also maps to heart, right? 9 maps to star, and 13 maps to the spade. Okay. Righto. Okay, so if you compare the first relation, the very first relation, and you compare the second relation, what is happening over here? Well, one of the things you can say is, Imad, if you look at the first relation, you find the values, none of the values map to the same thing. Each of the values in the source map to a unique value in the target. So I'm just going to write that down over there. Each value, or let's use the proper words, each element in the source maps to at most one unique value maps to at most one unique element in the target. Right, and there we go. So each element in the source maps to at most one unique element in the target. And if you look at this one over here, you'll say, well, Imad, if you look carefully, there's some elements in the source that map to more than one element in the target. I'm just going to put that over there. Some elements in the what? In the source map to more than one element in the target. So this map is not unique. More than one element in the target. Right. Okay. So let's consider this carefully. When we have unique values, in the source mapping to exactly only one value in the target, we call this a one-to-one map. So I can write it out as such, a one-to-one map. Whereas this map over here, I have some elements, right? For example, the 4 goes to both dot and it goes to heart. This here is called a one-to-many map. Right. It's called a one-to-many map because I've got one element, but it maps to more than one element, and therefore we consider it an element mapping to more than one, which means it's one to many, right? Because the 4 goes to the dot and it goes to the heart. Okay, so let's look at one more now, and then you can give me an idea of what's happening in each, right? I'm going to give you the source over there, and I'm also going to construct a target over there. We'll name this set A, and we'll say set A maps elements in, there's a relation, right, that's going to map elements in set A to set B. And so let's again choose some examples, 1, 2, 4, 7, 9, and 13, and then 27, put that as a number in as well. I'm going to put a cylinder over there. I'm going to put a triangle over there. I'm going to construct a cube on this side. Okay, my cube is horribly failing. Let's see if we can improve it. There we go. That looks like a much better cube. Okay, and let's put another dot there. We've got a cylinder, cube, triangle, and yeah. Well, I think that will do it for now. Well, anyway, let's start mapping some elements. I'm going to map 27 to the cylinder, 13 also to the cylinder, 4 will map to the triangle, and 7 also maps to the cylinder, right? While 2 over there is going to map to the cube. Now let's consider this carefully. I'm not going to waste time to express this in coordinates, but if we were, let's just select 2. 27 maps to cylinder, right? And so does 13. 13 also maps to the cylinder. Okay, and you can do that for the rest of the coordinates as well. Now, one of the things that we need to note here carefully is that I've got individual elements going going to the same thing, right? So there are many different elements that all map to the cylinder. So this type of map over here is considered a many to one map. So there are many elements in the source that map to one element in the domain, right? Yeah. Okay, and then finally, the last thing I want to discuss is I want to talk about the range, right? And so let's give us a definition for the range. Well, I'm just going to say the range is a subset, firstly, is a subset, right, of the target. Now, what do I mean by a subset? I mean that the range is actually made up of elements of the target set. Remember, the target is just here, the codomain, the set over here. This is the source. Set A is the source, and set B is the target. Set A again is the source or the domain, while set B is the target or the codomain. So there's a key difference to note. Now, if we look very, very, very carefully, one thing we have to consider here carefully is when we talk about the range, firstly, it's a subset of the target. That means it is made up of elements of the target. It can either be all the elements or it can be some of the elements. So for example, this over here, if I look carefully, just a cylinder on its own would form a subset of the target. Just a triangle on its own, which is some of the members of the target, that forms a subset. If I use all of it, it is called a proper subset. It is going to be a subset that contains the entire set of the target. Okay, so the range is a subset of the target. That's the first thing we need to note. And then secondly, it consists of the elements it is a subset of the target first, and then it consists of the elements that are mapped to in the target set. Now, if you look carefully, if we go back here, what are the elements you actually used, that you actually mapped to from the source or from the domain to the codomain? Which elements did you actually map to? So I'm going to just write over there the range, and if you look very, very carefully, the range is actually the set that contains cylinder, triangle, and cube. So a big mistake to want to draw. Oh, that cylinder sucks. Cylinder, triangle, and cube. Oh, that cube is bad. Okay, there we go. That's a cube. That will suffice for now. Ooh, very, very bad. Okay, anyway, just be doing our best over there. That's the range. If we look at this one over here, the range is actually the entire set because everything is mapped to here. So the entire set B is actually the range as well. If we look at this one over here, the range is just the cylinder, the triangle, and the cube because we didn't use this, so we didn't consider it the range. But the entire set is called the target. The subset to which we actually map to is called the range. And if I look at the first one, the range over here is going to be the set that contains heart, triangle, star, and dot. Okay, in the next video we're going to briefly talk about what exactly a function is.